Okay, so now it's recording. It's recording. Yeah. Okay. So, all right. So we have done isobaric and isochoric process. Isobaric means constant pressure. Isochoric means constant volume. So now we want to discuss what is adiabatic process and isothermal process. Okay, if you look at isothermal, yeah, I want to begin with isothermal first. We have constant pressure, constant volume. So isothermal is constant temperature. Yeah. So let me write over here. Okay. So we have isothermal. Yeah. Now we have isothermal process. So isothermal means same temperature. Okay, same temperature. So we can say it is temperature is constant. Okay, temperature constant. So only the pressure and volume changes. So if temperature constant, that means this one is using P1 V1 equal to P2 V2. So this isothermal process is actually the Boyle's law. Okay, it's Boyle's law. So it's known as Boyle's law. We have discussed about isothermal process PV graph. Let me refer. Yeah, this one. See this one? So it is Boyle's law. Yeah, this one. Okay. All right. So we know that to maintain constant temperature, okay, if you, let's say, compress the gas, pressure will increase. The curve must maintain at same isotherm line. Yeah, it maintain at same isotherm line. Maintain at, let's say, like this one, maintain at 400 Kelvin. Excuse me, maintain at 400 Kelvin. This one, Boyle's law. Okay, talking about the first law of thermodynamics. Yeah, which equation? This one, first law of thermodynamics. Yeah, let's look at this one, isothermal process, first law of thermodynamics. Okay, so somebody, okay, yeah. So first law of thermodynamics. So how to relate to this equation for isothermal process? Temperature must be constant. Temperature must be constant. So which quantity, delta U, heat or work done, which one relate to temperature? Which one, class? Which one relate to temperature? Remember? Which one relate to temperature? Look back at this one. Sign convention of Q, delta U, and W. Yeah. First law of thermodynamics. Which one relate to temperature, class? Q or delta U or work done? Yeah. Somebody give response. Which one relate to temperature? It is delta U, isn't it, class? Yeah, the internal energy. Yeah. So it is the internal energy relate to temperature. If work done relate to volume. Yeah, talking about expansion and compression. Yeah, work done relate to volume. Okay, so it's internal energy. Yeah, it relate to the temperature. So for this case, we say that the temperature is constant. That means, what can you say about internal energy? Also constant. Because internal energy, the formula is internal energy of gas is half 1 over 2 F and KT, isn't it? So internal energy relate to temperature. If temperature is constant, that means internal energy also constant. So right now, he say that temperature constant. So that means delta U must be temperature constant, no changes. Delta U must be 0. Understand? Delta U internal energy, change of internal energy is 0. So the equation of first law of thermodynamics for isothermal process is, so go to the other side. So Q equal to W. Okay? Everyone okay? No response Okay, class. Isothermal process must use a good conductor container. Yeah, that means it must made of good conductor. Okay, it must made of a good conductor. Good conductor means the heat can easily flow out or flow in. Okay, this is the piston. Okay, and isothermal process is a slow process. Isothermal process is a slow, very slow process. Very slow process. You cannot compress the, if you want to do Boyle's law experiment, you must do it very, very slowly. Because if you compress very fast, there'll be change of internal energy, change of temperature inside the gas. Okay, so inside there is a gas. It's a very slow process. Can you go to YouTube and search out examples of isothermal process? Okay, look, let's say, okay, I put it, let's say, if work done is negative, class, work done negative means what? Compression or expansion? Yeah, work done negative. Work done negative means compression or expansion? Compression, isn't it? Work done on the system. Yeah, compression. So work done negative means compression. So what happened to the Q? Become negative also. Negative Q means what? Negative Q means heat flow out. Negative Q means heat flow out from the system. Remember about this one? This is a system, the gas. Work done on the system, negative W. Yeah, work done negative means compression. Compression, the energy enter. Negative work done means energy enter into the gas. What I mean is, if you compress the gas, class, if you compress the gas, you are actually supplying energy into the gas. Supplying energy into the gas. So, if you compress the gas, the temperature by right should increase. The internal energy of the gas will increase. But to maintain the constant temperature or constant internal energy, we don't want to disrupt the internal energy. So this container must be made of good conductor. So that means we compress very slowly. Actually, energy enter. When compression, energy enter. But to ensure that the internal energy of gas don't increase or temperature don't increase, we do it very slowly. Let me, okay, so let me, okay. Okay, so when you compress the gas, actually energy enter. See that? work done on the system. Work done on the system means you compress the gas. Actually, energy enter. Look at the arrow here. Energy enter. But because we don't want the internal energy of gas to increase, you must make sure the heat flow out. Energy must escape from the container. So heat must flow out. Heat must flow out. So this is what we call negative, means heat loss. Heat loss. Yeah, energy flow out. Energy flow out. Understand? So in order for the energy to easily flow out, this must made of good conductor, and you must compress it very slowly so that the internal energy of gas don't suddenly increase. Okay, so compress the gas and heat energy loss. Okay, so that's what you mean by first law of thermodynamics lah. Everyone okay, class? Yeah. Okay, that's isothermal. The line must maintain at same temperature line. Okay. If volume decrease, pressure must increase. If volume increase, pressure must decrease. They inversely proportional. Pressure and volume inversely proportional. Boyle's law. Boyle's law is actually isothermal process. Okay, for isothermal process, delta U is 0. We have learned already like isovolumetric, because constant volume, so work done 0. For isochoric is work done 0. Isothermal is delta U 0. Okay, so the following process, adiabatic, is heat absorb 0. That's the following one. The fourth thermodynamic process. Where is it? See that? Adiabatic process. Okay, so for adiabatic process, no heat transfer. To achieve no heat transfer, this container must be made of insulator. Last time isothermal process, you see, is a good conductor. A metal pot, a good conductor. So adiabatic is the other way around. Must be insulator to ensure that no heat transfer between the gas and the surrounding. No heat enter, no heat loss. See, the other way around from isothermal. Okay, so adiabatic is no heat transfer. Okay, let's write down. Okay, adiabatic. Adiabatic. Okay, so what is adiabatic process, class? Can tell me what is adiabatic process? The heat is 0. Okay, class. Looking at the first law of thermodynamics. Okay, this one, first law of thermodynamics. Okay, so for adiabatic, last time isothermal process, delta U 0, isovolumetric, work done 0. For adiabatic is Q0. Q0. So okay, so Q0. So the equation becomes delta U equal to negative W. This is the formula for adiabatic. Okay. So how to understand? Okay, just now talking about isothermal process is a good conductor. So how about adiabatic? Adiabatic is a good insulator. Let's draw it out. Good insulator. Okay, a good insulator. If you can imagine this is a good insulator, then easy. Why must be insulator? Because we must ensure no heat loss or no heat absorbed from surrounding. Okay. Adiabatic. Actually, there is a video. There is a YouTube video. Show you what is adiabatic process. Yeah, very good one. Later I share to you. Yeah. Okay, so this is a insulator. Must be insulator, class. Must be insulator. And last time, isothermal process is a very slow process, right? Isothermal process is a very slow process. So how about this one? Must be a very fast process. Why must be very fast? To ensure no heat loss, actually. Everything is insulator. This one is a very fast process. For adiabatic, must be a very fast process. Very... Ayo, kaki kejang pula. Very fast process. That means what? We must do it very quickly to get the adiabatic. We must do it very quickly to get adiabatic result. You know, that means we must compress very fast. You know, we must compress very fast. For example, like look at just look at this formula. Compress means what? Compress means what? If compress, work done is positive or negative? Yeah. Go back to this one. If you forget, compression is work done on the system. Work done is negative. Compression. Energy enter. Understand? Energy enter. Okay. So compression, that means we compress the gas. Let me, how do I draw? Yeah? Compress the gas. We compress it. Compress. That means the energy enter. You know that? Energy enter. Energy enter. So if you compress the gas, means work done is negative. Correct or not? Work done is negative. Write it down. Write it down. Work done negative. But see, negative multiply negative. Yeah. Negative multiply negative. You get what? Delta U is what? Delta U is what? Positive. What happened? What is mean by positive delta U? So, you know, inside this one got gas, a system. This gas, this system has internal energy. Internal energy, understand or not? So if energy enter, if compress the gas very fast, compress the gas, if you do it very fast, you don't allow the heat to escape. Some more this is insulator. So no heat loss. The heat loss, Q equal to 0. No energy escape. No energy escape means all this energy enter into the internal energy of gas. That means energy enter into the gas. So what happened is the internal energy of gas increase. And also the temperature will increase. Understand? That's why delta U is positive. Okay? No heat loss. No heat loss. No heat loss. So insulator, you compress it very fast. So the energy from your work done, okay, this is compression is actually work done. Work done negative. Negative work done. Negative work done means energy enter. So energy directly enter into the gas. So the gas gain internal energy. When the gas gain internal energy means the gas become hotter. Become hot. Become hotter. Understand, class? Okay, maybe the other way around, class. How about if gas expand? If let's say the system expand, what happened, class? Tell me. Just use the first law of thermodynamics. Then you can explain. Delta U equal to negative W. Okay, so I need to redraw. Just copy paste lah. Okay. This time is I not compress, expansion. Expansion means work done by the system. Means what? Energy escape. Not energy. Energy used. I can say energy used. Who? Okay, let me delete all this. Okay, let's say inside there is gas. Yeah. Now expansion. Work done on system or work done by system, class? Expansion. Is it work done by the gas or work done on the gas? Expansion. Expansion work done by the gas. That means the gas do work. Isn't it? The gas do work. Who do the work? Is it you? Is it you or is it the gas? Gas push up the piston. It push up the piston. Expansion. Expansion. So this is work done by the gas. Work done by the gas. Work done by the gas. That means who do the work? The gas do the work, right or not? Okay, but there is no heat, there is no heat from outside go into the gas because it's insulator, so now is the gas do the work, right? Let me write it down. This is the gas do the work. By expansion, the gas push up the piston. Let me write everything. Gas pushes up the piston. Okay, so what happened if the gas pushes up the piston? This energy comes from where? How can the gas push up the piston? The gas actually use its own. Don't forget, gas got internal energy. It got internal energy reserve. So gas used. I can say gas uses its own internal energy to do the work. What work? Push up the piston. Gas uses its own internal energy to do the work. So when you use its own internal energy to do the work, internal energy drop. Dah berkurang kan? Sebab gas buat kerja. So dia guna dia sendiri punya internal energy to expand. So internal energy drop. So internal energy drop means what? Temperature also drop. Class, understand? Look at this formula. Yeah, adiabatic. Yeah. Maybe just now talking about expansion. Expansion is what? Expansion work done positive. Positive work done. Correct or not? Work done is positive. Darab dengan negatif, apa terjadi kepada internal energy? Negative positive because expansion. Work done by the gas. Work done by the gas is work done positive. Expansion. So negative multiply positive, you get negative. The delta U is negative. What is mean by negative delta U? Delta U negative means internal energy decrease, temperature decrease. Internal energy decrease because why? Gas use its own internal energy to do the work, expansion. So that's why the internal energy decrease, temperature also decrease, become cold. The gas inside become colder. Understand? Delta U negative. Delta U negative means internal energy decrease, temperature decrease. Okay, so I have explained quite detail for adiabatic. So now how about the graph? We already got the isothermal graph. How about the PV graph for adiabatic class? What is this? Let me. Okay. How about the PV graph, class? Are you listening, class? Are you listening? Yeah. Still accompany me, huh? Okay. Understand, huh? Semua faham kan? Boleh lah kan? Okay. So this is a pressure Pascal, pressure volume, meter cube. Okay, class. The graph actually is a bit curved. Let me draw first, yeah? Draw everything. Okay. Like that. Like that, yeah? So I put this maybe 300 Kelvin. Going further from the axis become hotter and hotter, right? 500 Kelvin. Now you can understand the graph. Class. So what happened, class? What happened? Adiabatic process. Okay, isothermal process. Let me go back to isothermal process. For isothermal process, the compression happen very slow. Compression happen very slow to make sure that the heat flow out easily due to good conductor. Yeah, if we compress, we must ensure that the energy flow out slowly so that the internal energy don't get disturbed. The internal energy don't get disturbed, so change of internal energy is zero. So this is isothermal. Let me write it down first. Isothermal process. From here, go to here. Let's say this is the initial point, this is the final point. This is isothermal. When we compress very slowly to make sure that the temperature don't change, the internal energy don't change. Okay, understand, class? Write it down. This is isothermal process. Isothermal compression. Isothermal compression. Okay? Because volume decrease, what? Isn't it? Volume decrease, yeah? See, look at volume decrease. Okay? Pressure increase. Isothermal compression. But make sure the temperature constant. But adiabatic, if you compress very fast, you disturb the temperature, you disturb the internal energy. The heat tak sempat flow out because this process happen in a very short time. The heat tak sempat keluar pun. Lagipun ini insulator. Heat tak sempat keluar. So what happen? Adiabatic compression, dia akan shoot up to a higher temperature. See that? I go to a higher temperature. The final point is here. This is adiabatic compression. Understand or not? It go up from 400 Kelvin to 500 Kelvin. Because why? When you compress very fast, the energy enter into the gas. Tak sempat keluar pun. Lagipun ini insulator. Yeah? The tenaga itu masuk dalam gas. So, it store in inside the internal energy of gas. It's stored inside the internal energy of gas. So when it's stored inside the internal energy of gas, the temperature of the gas increase. It go from 400 Kelvin to 500 Kelvin. Okay? So apa beza isothermal dengan adiabatic? Adiabatic lebih cerun, steeper. Adiabatic compression punya graph steeper. This one less steep lah, because maintain same temperature. Understand? Adiabatic compression. Tengok anak panah, pergi sana. So, okay, internal energy increase. So how about expansion? If you want to talk about expansion, then draw expansion lah. Okay. Okay. Understand? Okay. Okay, let me. Okay, expansion. This is isotherm line, isotherm line. So pressure Pascal. This is a volume meter cube. Okay, so this 500 Kelvin, 400 Kelvin, 300 Kelvin. Okay, let's say class, you begin over here, class. Initial point. Initial point. So let's say isothermal expansion. Isothermal expansion means it maintains same line. Understand? It maintains same line, same temperature. The process happens very, very slowly. Yeah, expansion. You let it expand very slowly. Okay. Maintain same temperature. But for adiabatic expansion, okay, let me write it down. Yeah, this one is isothermal expansion. How about adiabatic expansion? If adiabatic expansion, work done by the gas do the work. The gas use its own internal energy to do the work. So that means it will drop to a low temperature. It drop to lower temperature. It drop to lower temperature. Why? Why it drop become colder when adiabatic expansion? Let me write it down. Adiabatic expansion. So adiabatic expansion, it will drop to a lower temperature. Because why? Because gas use its own internal energy to expand, to push up the piston. So the gas will encounter energy loss. The internal energy of gas will decrease. It will drop to a lower temperature. So when adiabatic expansion, the gas become colder. The gas become colder from 400 to 300 Kelvin. So class, can you see the difference between isothermal and adiabatic? Adiabatic always steeper, bigger gradient. Adiabatic mostly bigger gradient. Isothermal less gradient. That's it lah. Okay. Anyway, adiabatic is law apa? Kita ada sudah Boyle's law, kita ada pressure law, kita ada Charles law. Macam isobaric is pressure constant, isochoric is volume constant, isothermal is temperature constant. Boyle's law. How about adiabatic? Adiabatic tiada yang constant, kelas. Adiabatic tiada yang constant. Cuma tengok kelas. Adiabatic compression, temperature ubah. Adiabatic compression, temperature ubah dari 400 to 500. Temperature ubah. Temperature not constant. Pressure also increase. volume decrease. Volume decrease. So semua pun semua pun berubah. Tak ada yang constant. So the moral of the story is none is constant. That means kita boleh guna formula apa? Untuk formula ini, adiabatic, guna formula ini P1 V1 over T1, semua ubah kelas. Semua ubah. P2 V2 over T2. Understand kelas? Okay? Semua ubah. Adiabatic lah. Nanti you buat nota sendiri Okay lah. Selesai. Isothermal, delta U0. Adiabatic, Q0. Yang work done 0 siapa? Masih ingat work done 0 siapa? Yang volume constant, no expansion, no compression. Itu work done 0. I think work done 0. So ada. Tapi for isobaric, tiada yang 0. Ini tiada yang 0. Semua pun ada. Delta U pun ada, Q pun ada, W pun ada. Okay, kelas. Finally. Lagi part terakhir, kelas. Kelas. Sometimes dia ada combine beberapa proses, kelas. Sometimes dia akan combine beberapa proses. Dia akan combine beberapa proses. Sometimes it will, pressure, volume. Dia akan combine beberapa proses. Like from here go to here. Isobaric. Isobaric process. And then isochoric. And then dia akan ada lagi isothermal. Kalau dia maintain at same line. Boleh juga kelas. Combine process. Let's say this is 400 Kelvin. Okay. So this one maybe this is 500 Kelvin maybe. Yeah. So can you mention what is this? Isobaric, isochoric, isothermal. Nantilah kita bincang soalan baru kita petang ni. Petang ni kita tengok apa soalan yang ada. Ya. Okay, what else? Work done. Lastly, yeah, I'm going to finish the whole chapter already. Then afternoon we can discuss question only. Work done. Ini saja formula dia. Work done. Okay, work done. Kita ada isothermal. Formula is this one. Work done is nRT ln V final over V initial or equal to nRT ln P initial or P final. That's isothermal. Isobaric, kita pernah buat ini. Pressure multiply volume final minus volume initial. Isochoric, work done 0. Adiabatic, mana adiabatic? Adiabatic tak ada dalam syllabus. Ya, tak ada dalam syllabus metrik. So kita hanya buat 3 saja. Only isothermal, isobaric and isochoric. Okay? Derivation class, integrate, know how to integrate 1 over V, you get ln V. This one I don't want to detail lah, I don't want to explain, yeah. You just read yourself, yeah. Integrate. Sebab kita guna formula saja, lebih kepada guna formula saja. Okay, this is for isothermal. Isobaric, senang. Just take the pressure multiply change of volume. Sebab dia segi segi 4 saja. Dia segi 4 saja. Senang. Isothermal susah sikit sebab dia curve. Tapi guna formula ni je. Nak cari area under the curve. Remember, area under PV graph is the work done. Macam ini. Kalau ini going to the right hand side is expansion. Expansion is work done positive. Like this one. Going to the left is compression. Compression, work done negative. See, work done negative. Okay, used to find the area under this curve. Use this formula lah. nRT ln sama ada you want to use volume or pressure. Cuma dia terbalik. Tengok, nanti saya explain. Okay. Isobaric. Isochoric, zero work done. Sebab no area under the graph. No area. Itu saja kelas. Finish our syllabus. Let's write it down over here. Isobaric. See? Isobaric process. I did write it down. Its work done is equal to pressure multiply change of volume. The rectangle area. Okay? Isochoric, work done zero. Isothermal, maybe this one. Isothermal is a curve. So this one, let me write it. Hold on a second. Let me. What is this? Okay. Pergi bawah. Yeah. Okay. Nice. Okay. This one. Isothermal. Isothermal. So very easy only. Just the formula and how to find work done for isothermal process. Boyle's law. nRT. What? nRT ln V final over V initial. Just take that. V final, like this one, compression. Work done negative. V final is what? 10. V initial is 40. Okay? Okay, V final is 10. V initial is 40. Temperature is 400 Kelvin. Temperature is 400 Kelvin. That's it, class. Class, we know that PV equal to nRT, kan? We also can, for initial point, it is actually P1V1. For final point is P2V2. Boyle's law, class. Boyle's law. P1V1. Yeah. P1V1. This one is P1V1. This one is P2V2. Yeah. Actually, this one I should write the other way around. Yeah. Write the other way around. So P1V1 is lower pressure, bigger volume. Bigger volume, lower pressure. Final point is higher pressure, lower volume. Higher pressure, lower volume. See that? So P1V1 equal to P2V2. So class, so I can say that P1V1, yeah, P1V1 is nRT. The T temperature is 400 Kelvin. 400 Kelvin, understand? 400 Kelvin. I also can make it, I can make it P2V2. I can make it P2V2. Understand? P2V2. That means, class, this one in front here, nRT, can change. Can change to, the formula it can change. It can change to P1V1 ln V final is V2 lah. V initial is V1. I also can use, if you use 2, then volume also 2. Yeah. Understand, class? Boleh? Boleh. Semua bagus. Ya, semua bagus. Okay, I can change. Okay, just now I saw that I also saw that V2 V1 can change to P1 P2. Why is that? This is also Boyle's law. Because you see, this one rearranged, I get P1, V2. Let us arrange ourselves. We know that P1, V1 equal to P2, V2. So now I have V2 over V1. That means V2 over V1. And then pressure go to the other side. See that? Pressure 2 go the other side. V1 go to the other side. So, got it. Pressure 2. I don't confuse you lah. Just stick to NRT. Just now the V final, V initial. So I can put it as is pressure initial over pressure final lah. Okay, understand class? Or how do you want it? You like V2, V1? This one you like it more using P1, P2? Either way lah. No big deal lah. Okay? This formula is provided in the list of formula lah during exam. So make sure you know how to use it. Okay? So I think that's all for thermodynamic class. You have successfully finished the whole syllabus. So this afternoon I will explain the questions. Yeah, for thermodynamic. What are the questions? Question 8. Question 7 done already. The first law of thermodynamic. Question 8, question 9, and question 10, 11, 12. Okay lah, boleh lah, ya. Mungkin 3 question, ya. Break it, ya. Take a break later. Okay, thank you for listening. Alright, make sure siapa yang tak ada di sini, semua ada kan? Rewatch the video, okay? Okay, thank you class. See you in the afternoon.
Thank you, sir.
Yeah.
Thank you, sir.
Thank you, sir.
Thank you, sir. Thank you, sir.
Yeah, welcome.
Thank you, sir.
Thank you, sir.
Okay.